Welcome to the workshop at the Concord Free Public Library. My name is Christy, and I'm here today to show you how to safely operate the workshop's RevoPoint Pop 2 3D scanner. Our 3D scanner uses cameras and depth sensors to create digital models of three-dimensional objects. These models are most often used for 3D printing or virtual or augmented reality projects. This video is designed to introduce you to the simplest and most common use for our 3D scanner, scanning a small, simple object for replication on one of our 3D printers. If you're a more experienced user, rest assured that our 3D scanner and software is also equipped to perform full-color, large format, and marker-based scans. We just won't be covering those techniques here in this video. If you're looking to go further, you can find the complete user manual on the manufacturer's website at cfpl.info/3D scan manual. Start by choosing an object to scan. The easiest objects to scan are small, have a flat base, are light in color, have distinctive textural features, and have an opaque, matte surface. Dark, shiny, and transparent objects can be difficult for the scanner's cameras to see. If you're interested in scanning a larger object, an object that doesn't have a flat base, or an object with smooth, consistent planes like a ball or a cylinder, you'll need to do some additional reading about the advanced features of our 3D scanner. Again, you can find the complete user manual on the manufacturer's website at cfpl.info/3D scan manual. In this video, we'll be scanning the sample bust included in our 3D scanning kit. Okay, let's get making. Choose a well-lit surface to serve as your workspace. For the very best results, we recommend reserving the workshop's AV lab along with the scanner so you can use our professional lighting kit. Place the object you'd like to scan on the turntable and turn it on. Slot the 3D scanner into the tripod and attach the provided USB cable to the back of the camera. Be careful not to touch the lenses on the front of the scanner as you work. Connect the other end of the cable to a computer or smartphone and point the camera at the object you'd like to scan. Now it's time to open RevoScan, which is installed on all workshop computers and available for free download for Windows, Mac, Android, and iOS at revopoint.com. In this video, we'll be using RevoScan 5 for Mac. Once the software detects the scanner you've connected, click New Project and assign it a name to enter the scanning interface. There are a lot of controls here, but don't panic. It's more intuitive than it looks. On the left side of the screen, you can see what the scanner is currently seeing through both its regular color camera on the bottom and its depth sensor on the top. On the right side of the screen, you can see and edit the current scan mode and settings. You can scroll down this menu to read brief descriptions of what these settings do. To start scanning, adjust the placement of the scanner until most of the indicator bars fall within the excellent range on the scale on the right side of the preview. It's fine if your entire object doesn't fit in the frame right now. When you're happy with the placement, press Start to begin scanning. The large preview in the center of the interface will display the model being generated. Once you've made it all the way around your object once, you can adjust the scanner or even pick it up to get another angle on the object. Repeat this process as needed until you have a full scan. Just be sure to move as slowly as possible to give the computer time to track the object. Don't worry too much if you pick up background objects in your scan, like the table here. You'll have a chance to edit this out later, but if you find you're having a lot of trouble with this kind of scanner noise, you can cancel the scan and adjust the sensitivity of the depth camera, or try laying down a piece of black fabric under and behind the turntable to help disguise the background. When you're happy with your scan preview, you can click Complete to move into editing mode. Click One-Click Edit, then Apply to process the scan output into a preliminary model. Again, there are a lot of options here, so take your time to experiment with the tools and remember that there's always an undo button in the bottom right corner of the interface if you make a mistake. In the center of the interface, you can rotate, move, and zoom in and out on the model you've created. If you're a beginner, you're mostly going to want to use the tools in the Mesh Edit menu at the top of the screen and the selection tools in the right sidebar. If you have any extra scanner noise in your scan, it's easy to clean that up now. First, rotate your scan so that the area you want to delete is clearly visible, then choose a selection tool from the sidebar and use it to select the area you want to delete. Once the material you want to delete is highlighted in red, press the trash can button in the right sidebar or the delete button on your computer keyboard to remove it. Repeat this process as many times as you need to until you're left with just the object you want. You might notice some holes in your scan. Holes are created wherever the depth sensors didn't get a clear reading during your scan. If you have a lot of holes in crucial parts of your object, you may want to cancel and try scanning again. But if you just have a few holes, you can use the Fill Holes tool to let the computer take its best guess at the missing textures without needing to rescan. First, choose Fill Holes from the Mesh Edit menu, then select whether the holes should be filled with flat planes or with curved shapes, and click Detect. Now rotate your object and choose each of the holes you'd like filled using this method, and click Apply. Finally, you can use the Smooth and Simplify tools to select and smooth out any unnaturally rough spots in your scan. There's also a Brush Smooth tool in the right menu bar you can use for quick fixes. Make a mistake? Remember that you can always use the Undo button in the bottom right corner of the screen to go back a few steps. Once you're happy with your scan, choose Export in the top right corner of the screen. Select Mesh Model, and choose the file type you'd like your object output as. If you're using the workshop's 3D printers, you'll probably want to choose STL. Finally, if you're planning to print your model, you may need to do some additional file cleanup in a regular 3D file editor like Tinkercad or RevoPrint before slicing. The Rotate Surface to Platform and Move Object to Platform tools in RevoPrint are especially useful for straightening out scans to be more printer-friendly. Keep in mind that all the regular 3D printing rules apply when printing a 3D scan, so objects with overhanging parts will need supports, and objects with uneven or very small base surfaces may have trouble staying adhered to the print bed. Here's how my scan printed out on our Robo E4 printer. You might notice it lost some definition, and that's really normal unless you do a whole lot of technical work to help maintain all the details. Keep in mind that our scanner is consumer grade, so it's designed for hobbyists. You probably won't have a lot of success duplicating your house key or precise mechanical parts unless you're willing to put in a lot more hours of studying. Congratulations, you're now a trained maker. If you want to learn more about everything our scanner can do, you can find the complete manual on the manufacturer's website at cfpl.info/3dscanmanual. The workshop is made possible by the generous support of the Concord Free Public Library Corporation, a charitable organization supported by makers like you. Learn more about all the corporation does to make our library awesome and how you can help at cfpl.corp.org. And if you just can't get enough making, be sure to check out the workshop's full library of maker tools at cfpl.info/workshop.